Hi, welcome back. So we are in chapter 3, you must know, in the outline of equation, function, and system. I hope by now the idea of equations is quite clear to you and how it is important. In order to start to speak the language of mathematics, you must be able actually to translate any problem into a mathematical equation, and then from equation you might sum number of equations into a system and then extract certain function, and that is actually the model that can help you to start to understand what is production is all about. As we have explored so far, the linearity of an equation. So we have just seen a linear of equation, but how about if this line that we were talking about, it takes other form of curve, for example. This is where we encounter into something called a non-linear equation. To illustrate that, let me take you to the following illustration. A linear line means that the actual change of y here, it's just equal to the actual change of x in here. So the distance from here to here is just equal to each other. As we said, the delta of y over the delta of x, it is just a constant number. It's not going to change. So take any point on this line and measure the change of y. As x was changing, it will always get back to this particular number of c. In the second thing I would like to show you is a different problem. Each point has its own unique alpha, right? And as we said, production means I'm looking for a general alpha that could fit into all these together. And in order to do that, we are trying, in other words, to find a line that started from somewhere where both coordinates may be from the origin and connect them. So you could see the line here isn't a linear. It is not like a straight line like the previous problem. You will see that in this particular first point here, the change here over the change of x, it isn't equal actually when we came to the second point here. And what we're trying to do actually to capture that change at every point. As you could see here, this quadratic line, it has across all the points. I'm going to work on the first point on this line. I would like to draw a linear line. So how to draw a straight line? We know the form of polynomial of y is equal just sum alpha multiplied by x, right? So the question is, what is the alpha here? The alpha here should be the change of y over the change of x, right? Multiply, of course, by the indeterminate. And then I would like also to add the intercept in this case. The line that I have drawn just now from this equation is just tangent only with this point on the equation of x squared. Now I'm going to add one more line here to be tangent to the second point, which is 2 and 4. And that's going to be 8 over 2 minus 4. And you could see it's a tangent with exactly this point. One more, if you like, I could do that. I hope now you start to see the pattern what I'm trying to do. And you could see that the line here is just tangent with only this particular point. What I'm trying to say here, if you look at these lines that I have drawn, the first line, the second line, and the third line, I consider the intercept of this line, okay, the first line, it's equal exactly to the y point. And then I double the value here as the change happening on y over 1. And in the second line, I did the same. I take the same intercept as y. I double the value to be 8, the value of x to be 2 as it is, and so on and so forth. Now, if I want to do the same exact thing in a cubic form, you could see what I would do actually exactly the same thing as I did before. However, this time I'm going to double the intercept and then add to it the value of the y. So it's going to be 3 over 1 x minus 2. It was tangent only with this point. I will do one more line just to show you the pattern here. So in this case, it's going to be 24 over 2x minus 16, tangent only with this point as expected. So let me show you a better presentation to explain why I am doing that and what do I mean. Now, I have created this to show you that when my equation was just only a linear one, the coefficient was always constant. It's 1, 1, 1, 1. Now, when I took a quadratic form x squared here, so it's going to be 2, 4, 6, 8 if we get back here. Now, if you look at the difference, the ratio of each alpha for each line, it is 2 and then 4, so on and so forth. So the idea here, it is the same. Then what I did one more round by subtracting the values. I get 2, 2, to I get into a constant. Now, when I went to power of 3, in the first round, coefficient was a 3, 12, 27, 48, and so on. Then I did the second round by subtracting 9, 15, 21, 27, until the third round to get a constant number once again. Power of 4, the exact same thing. So it needed me 4 rounds to get to a constant number of 24 and so on. So what I'm trying to say from this, that if you would have these points, all right, and you don't really know exactly what is the power of this particular function, this mechanic that I have invented myself, power by round, that I would draw a single line for each one of them. Then I would watch the ratio difference of each line, and then I start to kind of root them until I reach to a constant. Now, the number of rounds that needed me to reach to that constant, I call it the power of that equation. That was the end of this session. Last but not least, I'm going to discuss a comprehensive example. I will see you then.